Hello friends, today we'll be doing a question related to the starting of induction motor with the help of auto transformer. So the question goes as, the starting current of delta connected three-phase induction motor is 5 times at rated voltage is 5 times the full load current and the slip at full load is 5%. Okay, the no load current is negligible. If the auto transformer is used to limit the starting current from mains to 2 times the full load current, then what is the percentage of starting torque as the percentage of full load torque? Okay, so here auto transformer has been used to start the induction motor. So these are the stator windings and this is the rotor. Okay, the stator windings are delta connected as shown, and these are the tappings of auto transformer, the blue ones. And from here the supply is coming, so there is somewhere mains here, okay, which is not shown here, but from there the supply is coming. So if you connect to these black dots, that will be the mains, okay, directly from the mains, because the transformer has no effect now. So when you connect this to these points, okay, you would directly connect to the mains. So for these kinds of problem, you use the formula tau starting means starting torque over tau full load equals to I starting over I full load whole square into IS into SFL. Okay, so I starting is the starting current, IFL is the full load current. Same, tau starting is the starting torque and tau full FL is the full load torque. Okay, so once then how to proceed for these kinds of problems? So what we can do first is we can see what is known to us. Slip at full load is known to us, which is 0.05, because it is 5%, so it will be 0.05. Now the first case is he's saying that when there is no, the full load voltage is applied, okay, the full voltage, okay, the V is applied. So how that is applied? The tapping is connected at point, this point, okay, this black point. If the tapping goes from here to this point, same it will be for the other two phases also. So when it goes that way, okay, then what will happen is the full voltage is applied. Okay, in that case he's saying the full load current, okay, 5 times the full load current is flowing in starting. So say our I starting is, okay, say our I starting is, say, ISC, okay, when full load voltage is applied. Okay, so ISC is our starting current. Okay, so that ISC is going to be 5 times IFL. Okay, this is what he's saying. Okay, so this is our ISC. Okay, now this ISC is proportional to V. Okay, okay, now say our ISC, this voltage drops to XV, where X is less than 1. Okay, in case of auto transformer this X will be less than 1. So what will happen is the voltage will be X of V, okay, and the current will also decrease in that proportion, the starting current. So that starting current will now become X of ISC. Okay, okay, so that is what is happening. So when you tap it somewhere, this current becomes X of ISC. Okay, now once this current becomes X of ISC, due to the transformer action, this current, okay, which is the mains current, it will be X square times ISC, because this is the high voltage side. So the current has to further drop, and it has to drop by the ratio. Okay, so the transformation ratio is X, so this is X square times ISC. So this X square times ISC, okay, let me write it again, this X square ISC and this is ISC. Now this X square ISC is, he is saying that it becomes, it is now only 2 times of IFL. Okay, so this is given to us. Okay, so this is given to us, and what is given to us is ISC is only, it is 5 times of IFL. Now these two things are given to us. Okay, now let us put them in the formula and let us see, okay, whether we can derive this or not. So now again I will write tau starting over tau FL is equal to I starting over IFL, okay, whole squared into SFL. Now you can see here that when this is XV, the starting current is X ISC. That's what we did in the previous slide. So this is now tau starting over tau FL is equal to, this I starting is x times ISC, okay, because the voltage is x times V, and IFL, okay, as it is whole square SFL. So again, let me write it clearly. Once V tapping is used, then tau starting over tau FL is equal to x times ISC over IFL, okay, whole squared into SFL, okay. This is what we have with us. Now this can be further written as x square into ISC squared over IFL squared into SFL, and this can further be written as x square ISC over IFL into ISC over IFL into SFL. Now you know that x square times ISC that we have derived earlier, okay, in case of the line current, this is the line current. In case of tapping, it is 2 times of IFL, okay, this is 2 times of IFL, okay, this is the first thing, okay. And also when full load current is applied, the current is ISC, full load voltage is applied, then the current is ISC, and it is 5 times IFL. So can we substitute x square ISC as 2FL and ISC as 5FL? Yes, we can do that. So what we'll do is tau starting over tau FL is equal to x square ISC is twice FL, okay. So instead of this, I have written twice IFL, okay, instead of, sorry, this I have written twice IFL, and instead of this one I am writing as 5IFL, okay, into 5IFL into SFL. Now you can see that this is again divided by IFL, and this is also divided by IFL. So these two get cancelled, okay. Now what you can do is, we are left with 2 into 5 into SFL is 0.05, okay. The slip is 5%, as you can see here, this is 5%, so it is 0.05. So this comes out to be 10 into 0.05, so which comes out to be 0.5, okay. So if we write the complete relation, it is tau starting over tau FL is equal to 0.5, or tau starting is equal to 0.5 of tau FL, okay, tau FL. So tau starting is equal to 50% of tau FL. So the starting torque will be 50% of the full load torque. So this is how you can proceed for the problems related to auto transformer start for induction machine. Thanks for watching.